solving our physics subject GRE 21 to 23. And be sure to subscribe to my channel. Okay, so 21 say that give you some O and O prime and ask you about what? Then space-time interval. Okay, so common special relativity question. So what is the space-time interval, right? So the metric in the special relativity is here. Okay, so that's easy that we calculate dx squared plus dy squared plus dz squared minus dt squared. Okay, so we have x difference is 2 squared, 0 squared minus 2 squared minus 2 squared. So it's 4 plus 4 minus 4 is 4. So ds is 2. ds is 2. The answer is C. The answer is C. So special relativity probably is the most important topic in the subject GRE. So 22 that which of the following statement most likely to see electromagnetic field before under Lorentz transformation? Nice. So I would suggest that you remember how to transform the electric and magnetic field. Basically, I would suggest that you remember this. You remember this kind of formula. Basically, you can go to Google, Wikipedia, and you can see how to prove, how to see this, and then or go back to see your graphics. But the good thing is that we don't have to understand so much. All we need to understand is the E and B will form the so-called electromagnetic tensor, and the electromagnetic tensor will have the Lorentz transformation. When you do the transformation. When you do the Lorentz transformation, then you will become second rank tensor to second rank tensor. So this tells you that the E and B will mix together. Okay, this is all you need to know. Okay, so the A said that the electric field transfer completely into a magnetic field. By the way, this is impossible. Okay, because E and B will mix together. So sometimes if your system has no E, then there will be, and after you changes, the electric field may turn into magnetic field, and magnetic field may turn into electric field. So B said if there initial electric field after transformation, there might be both. So B is correct. B is correct. C, D, and wrong. C, D is wrong, right? Because electric field and magnetic field cannot be separated in the Lorentz form. So basically, in Lorentz form, they will form a second rank antisymmetric tensor. E said that it defines use gauge transformation. This is not correct because gauge transformation appears at the vector potential and the scalar potential, but not an electric field and a magnetic field. So the answer is B. The answer is B. So this basically just if you have roughly some idea about this, then it's enough to answer this. So 23 asks about conductivity, about temperature and the pure silicon. The conductivity of the pure silicon and the pure copper. Okay, so basically you know is copper is the metal, and the silicon is the semiconductor. So that means if you dope something into the silicon, then dope the 3A or 5 element into the silicon, then the conductivity will suddenly increase. And for the copper, if you dope, then I guess the conductivity will decrease. Okay, so this is a common sense that you once you know that you can solve it. Okay, so the first one, the conductivity of copper sample is many orders. So basically, this is because in the pure set, the copper is metal. So metal has the large conductivity. The temperature of the copper sample is increased. Common sense, right? If the temperature increases, the metal conductivity decrease. And C that if the temperature silicon sample is increased, the conductivity will increase. This is also correct. This is a property of semiconductor. The D said additional impurity in the copper sample is always decreased. Always decrease as its conductivity. So 24. So this. So doping a conductor like copper will make it the conductivity decrease. So yes. So number 5 said that additional impurity in silicon always decrease. So E is wrong, right? I already said that when you added the impurity in the silicon sample, then it will increase its conductivity. So basically, 23 just asks about whether you know that the silicon is a semiconductor. If you know the silicon is a semiconductor, then 23 is simple. So that's it.